Good morning, students. Today we are going to discuss about the new topic, that is elimination of the errors. So now we are seeing the mathematically how the errors can be eliminated. Now we will discuss how many different types of errors are there, how they can be eliminated. First of all, let us discuss what is an absolute error. An absolute error, so it is basically defined as the difference between the mean value and the measured value. Measured value, measured value. So, for example, if you take different readings A1, A2, A3, so on, AN, and there two let A1 different values are there, A2, A3, so on, AN, and A bar is their true value. Now let us take the mean of all these one. Or true value or their mean. Let us say A bar is the true value or mean value. Mean value. Then the absolute value, let us say for first one, delta A1 is equal to A bar minus A1, means my mean value minus the value. Then delta A2 is A bar minus A2. So on, delta AN is equal to A bar minus AN. So this is called as the absolute error. Now we will see mean absolute error. Mean absolute error. So how will you define it? Mean absolute error is defined as, so it is the mean of all these absolute error. So it is delta A1, delta A2, but with their magnitudes only, plus so on, delta AN divided by N. So this is called as the mean absolute error. Now next is about the relative error. Relative error. Now what is that relative error? It is the mean absolute error, mean absolute error, um, error divided by the true value. True value. So that means it is delta A bar divided by the A bar. So that is the mean absolute error. Sorry, relative error. Now next we will define is what is called as percentage error. Percentage error. So it is the absolute error, this relative error into 100. So that is the called as the percentage error. So this is the way we are going to do all the measurements and the calculation using different formulas, and which will be helpful in calculating different kind of errors. So now let us give an example. So where we will show how these errors are going to be measured. For example, let us for example take five values are given: 1.64, 1.63, 1.64, 1.65, 1.63 and 1.64. These are the six values which are being given. Now let us find first of all the mean. Mean of all these, add up all the values divided by 6. 1.64 plus 1.63 plus so on up to 1.64. So when you solve it out, it comes out to be 1.64. Now let us find the absolute error, delta A1. Delta A1 is mean value. So A bar minus so 1.64, so it is about 0. Second value delta A2 will be equal to A bar minus 1.63, so it is 0.01. So similarly all the values are being calculated. A6 A bar minus 1.64, so that is equal to 0. Now third value was 1.64, 0. Fourth value was 0.01. Fifth value was 0.01. So all these values are going to be taken up. So in some cases these values will be positive, in another cases it will be negative. For example, 1.64 minus 1.64, 0, it is 1, it is 0, it is minus 1, it is plus 1, it is 0.01, it is again 0. So all these values are going to be taken. Now let us find what will be the mean absolute error. So mean absolute error will be equal to, absolute error will be sum of all. Sum of all means this, all this. This will be 0.01 divided by 6. So this is the mean value, mean absolute error. Now let us start. What is about the relative error? Relative error. So that is equal to relative error will be equal to 0.0116 into 1.64. So this is a relative error, and then we will get the percentage error. So that is equal to 0.01 upon 6 into 1.64 into 100. So that is called as the percentage error. So this will be cancelled with this one. So 100 divided by 164 into 6. So this is called as the percentage error. So this is how we can able to make the measurements of all the calculations using a simple examples. Now next, how these errors can be propagated. Errors can be propagated. Errors propagation. So propagation of errors, for example, two quantities are there. Let us say length is have got an error of plus minus 0.1%, or breadth has an error of plus minus 0.1%. What will be their propagation area? Area is multiplied by length into breadth. Now similarly, it could be the error in perimeter. Perimeter is twice into length plus breadth. So similarly, so all these different parameters, some are in multiple, some are division, how these errors can be propagated. So let us say the propagation of error is always in the form of delta L plus delta B, whether it is multiply, whether it is added out. So all this, in both the cases, it will be plus value. This one is called as the absolute error. So absolute error will be added up. So in case of plus, in case of multiplied. Similarly, in case of subtraction also, so this is the value we are going to take. In case of division also, so this is the value. So division also same is the case, we are going to take it out. And similarly, now this propagation will be different if you take the power. Now let us say x is equal to a raised to m. So the delta x is equal to m into delta a. So power will be come out here, multiply with the error. Similarly, x a m over b raised to n. So it will be m into delta a plus m into delta b. So all these values are going to be taken one by one. So this is the way. Now if you multiply all these by 100, so you will get a relative error. So this is how the propagation and the control of errors going to takes place.